everyone, welcome back to our YouTube channel Becoming a ROS Developer. I'm Desire and today we've got David who has just completed the course Linux Basics for Robotics and he'll be giving us a presentation on that. So what I'm going to do is hand over the platform to him so he can begin his presentation. Alright David, whenever you're ready.
Sure, thank you. My name is David Hubert. I am in the United States and in sunny Tampa, Florida, and I have just completed the Linux Basics for Robotics class.
Mm-hmm.
And I would like to demonstrate my lab work that I did on a live robot. So I'm going to get ready for that. I am going to open up one more terminal window, so I have a total of three.
Mm-hmm.
Um, And I'm going to, on the first one, well, okay, I guess I didn't click it. So on the first one, I'm going to change into my project directory and going to run a Python script. This is what's going to get my bash commands that I learned about
Mm-hmm.
talking to the ROS2 system.
Okay.
And so that's something I have to do. I didn't really work on this script. That was something that was given to me.
Mm-hmm.
In the next terminal window, I'm going to load a bash script that I learned about that will give me some statistics on what the robot is doing.
Mm-hmm.
And I did work on that. Right now, it's not doing anything, so it's going to be reporting zeros. And in the third terminal window, I'm going to run my obstacle avoider script or bash shell that I did work on that will actually make the robot move around.
Mm-hmm. Mm-hmm.
I'm just making sure this says ready. That's helpful. Terminal 2 is actually reporting information, and I'm going to go ahead and hit enter. That will run my obstacle avoider script, which should make the robot start moving around.
Mm-hmm.
And if he detects something, he's going to turn. He kind of acts like a fancy vacuum cleaner, or a Roomba or whatever.
Yes,
It
right.
kind of moves randomly. Doesn't make a whole lot of sense, but that wasn't the actual. We weren't really learning about obstacle avoidance. We just kind of used it as a way to demonstrate our use of these bash shells, which is very interesting. Normally in ROS2, you would maybe create Python scripts or maybe C++, but here we demonstrated that we could use Linux and use these shell scripts that make the robot do stuff, which was pretty interesting.
Mm-hmm.
All
Yeah.
these all these scripts I had to use this chmod to make them executable and copying, and I guess it didn't avoid that obstacle too good, but
Yeah.
um,
I think that so there are some issues with how LiDAR works, I guess. So if it sees the obstacle on the edge, or if the thinner side is facing the robot, then it can struggle to see perceive it.
yeah, it seems like it does very well with the solid walls, and the red looks like a package here to me, but
Yeah, yeah.
so I
So
don't know if you have any questions, but this is basically the live script that I have.
mhm,
Oh,
yeah.
and let me take you to Terminal 2, which is kind of giving telemetry data, I call it, of the robot. So that's what this script is doing. It's just kind of reading the messages from ROS2 and displaying them,
Mhm,
the direction, the position, orientation, how much it's actually traveled.
mhm.
Uh, so, and if that could conclude the live demonstration if you'd like, but
All right.
this is what it does.
All right.
So
Wonderful. Wonderful.
what I do here is I exit out of the Python script first, and it kind of, well, yeah, okay, it stops the robot, and then I exit out of these other ones. Um, Now when I disconnect from the robot, it's going to change my shell scripts
Okay.
or my,
All right.
so I'm going
So
to just,
before we do that, so I wanted to know
oh, yeah, 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 sure thing.
your choice for how much the robot turns, right? So, because I noticed that when it was about to hit an obstacle, right, it would rotate beyond 90 degrees, right? So, did you have to play around with that, or you just wanted a safe margin?
I I actually use the values that were provided.
Mm-hmm.
I did not tweak those at all. I just left it to default values.
Mm-hmm. Mm-hmm. All right, understandable. Yeah. All right. So,
Um,
in general, maybe we can get to some Linux basic stuff because I think that that is the fundamental objective of this course, right? To be able to understand how Linux works. And so, in general terms, what would you regard as the perfect usage for Bash scripts? So, obviously, we're doing a lot more than we should we should do with them, right? As you said earlier, we are supposed to be using either Python or C++, right, to have the robot do these things. But um, going in that direction a bit, what do you consider to be the perfect usage for Bash scripts, especially in our endeavor?
well, I guess it could help definitely set up the environments. We didn't really demonstrate that here, but maybe things that you did all the time or you repetitive tasks. I think you could probably use the Bash scripts for.
Mm-hmm.
Definitely setting up your environment. There's actually I didn't create any for this project, but like if you had to set up something all the time, I think it would
I do.
be great.
Mm-hmm.
Um, but just in general, just learning some of the Linux commands, there are a few that were new to me. I kind of like the htop, kind of gave you a um, like what the computer is doing. I thought that was kind of interesting. I didn't know how to set up SSH. That was something that you covered in this class towards
Mm-hmm.
the end. I thought that was very interesting because I could see somebody having to do that
Mm-hmm. Yeah,
for, if
definitely.
it wasn't set up with the default install of Linux, maybe that would be something. And PS I wasn't familiar with, and how to kill a
Kill off process.
using
Yeah.
kill off process. I thought that was kind of neat. Everything else is just kind of moving files, takes a little bit to get used to that. And chmod is definitely your friend because all these scripts you had to add the plus X on there to get it to be executable.
Mm-hmm. Mm-hmm.
Um,
And I'm guessing PS came with another term, so FAX, PS Fox or FAUX.
yeah, yeah, yep.
And have you used that one before, or what do you
No,
consider the useful
no,
part?
I did not, I did not know about that as well.
Okay,
Yep.
all right. Yeah, so it does give you a listing of some of the processes that are running as well. I think it does a job similar to what HTOP would do, maybe with a lot less detail, but yes.
Yeah. And then using grep to filter out and look for certain, I think in the example we searched for ROS2 or something like that to filter through all the processes.
Mm-hmm. All right, so because you had to use multiple base scripts here, can you explain to me the process that is analogous to an input statement in Python or an include statement in C++? Like, which one is it in Bash?
Well, Bash, for the scripts that we had to create for this lesson, in fact, I could bring them up.
Mm-hmm.
Well, it'll take a second here.
Mm-hmm.
I can list them out. So, um, in the demo, the first thing I ran was this robot interface dot Python. So that's a Python script that kind of had handled all the actual ROS2 messages.
Mm-hmm.
And our we had a robot, um, the robot functions, which we had to create one of the exercises, handled that interface to the Python script.
Mm-hmm.
So let me show you, go navigate to that folder. So these are all the robot functions that we could do. Most of them are gets, which are like the scanning,
Mm-hmm.
and there towards the end, there's a few at the end that actually do the set, which move the robot. So linear velocities and angular.
Mm-hmm.
And, and then like my script to move the real robot access these functions.
Yes. So I want an explanation of how that is done. So I think you're getting to answer my question slowly.
Yes, here's the source. So that source, the robot functions I just showed you,
Mm-hmm.
where I said most of them are gets, but there's a few sets here, which this it tells the robot to stand still
Mm-hmm.
when
Mm-hmm.
it first runs, and then it goes through a loop, which it reads a bunch of the sensors and then decides how to move.
Mm-hmm. All right. So basically, the source makes available what is in another base script, right?
Yeah, so yeah, it's calling the robot functions bash script shell.
Mm-hmm. All right. All right. So let me see if I have any more questions here. All right. So I believe you tried to do some things in the simulation, right?
Yeah, yep, I have can do the same thing in a simulation. I need to disconnect from this robot,
Mm-hmm.
from the live one.
Yeah.
So I'm going to go ahead and do that. Yeah, the way you guys have this whole environment set up is really pretty impressive. I can
Thank you.
see why people like to use this.
Yeah, it makes it
So
very easy to transition, um, especially in testing.
yeah, so for the simulation, I actually need four terminals to be up.
Mm-hmm.
So I'm going to do that. In the first terminal here, I'm going to get well, I changed into my folder, and I need to run the simulation system comes up, including the turtle. So just kind of have to wait for that to come up.
Mm-hmm.
I should get two screens. Not sure why they've been disconnected.
I think it's probably some network issue, but just click reconnect, it should be fine.
Yeah, I did.
Anyway, let's talk a bit more about execution permissions and ownership in Linux, right? So I believe you came across
Yeah,
this. And
yeah, I can.
which three owners do you get, and how do you allocate permissions to each of them? If you can show.
Yeah, I don't know if you can see
Yeah, maybe enlarge it
my
a little
little.
bit. I can see it, but I think for the audience they may struggle.
Oh boy, not sure
Maybe you
how
can
I.
press Control plus on your keyboard. I think that should zoom in your screen a little bit. Yeah, okay, that's fine.
Okay, I'm gonna hit reconnect here while we're waiting to.
Okay.
Oh, I think that one's got a good. Yes. Oh yeah. So that's coming up. Let me hit this one. So I did the LSSLA. That kind of gives you a more detailed list of your files.
Mm-hmm.
And what it shows are the different permissions that each one of these files have.
Mm-hmm.
Uh, and to get them to execute, I had to do the chmod command, and I did chmod plus execute, and then I would give it the file name,
Mm-hmm.
and that would go ahead and give uh, execute permissions to it. As far as the other groups, I'm not as familiar with those. I just know for what I had to do, I had to add execute
Mm-hmm.
permissions. And I know there's different categories of permissions here. I would have to probably look that up.
Mm-hmm. Mm-hmm. Yeah, there are three
But
groups. So.
this, yeah. So like this one has execute for all three. And these, let's see, the last one I did was the sim one. I had a special script just for the sim.
Mm-hmm. All right. All right. So let's see how it would work in simulation environment. I think
Yeah,
let's
yeah.
quickly choose the sim and let's see.
This other 3D view isn't showing up. Oh, there it is. Okay.
Yeah.
Okay. So in the first terminal, we have the simulation running, and the second uh, terminal, very similar to what we did in the live. I'm gonna launch the interface, a Python script. You can
Mm-hmm.
tell it's Python by the PY. It's gonna let the bash scripts run,
Mm-hmm.
able to run. And three, I'm gonna do the same thing I did before, which is the robot statistics, which it's not moving now, so it shows pretty much zero. Of course, it does show a little bit that it moved, but don't understand that. And then four, this is going to be my obstacle avoider, and I do have a different one just for the simulator.
Mm-hmm. Can
Uh,
you take us through the reasons why?
when I was first testing it, I saw that I didn't know what the difference was, but I saw there were two different scripts, um, sample scripts that they gave us, one for the real and one for the sim. So I went ahead and followed along with that, and um, I just did it the same way, and I just created one called sim, and the other one was real.
All right.
And
You didn't do a side by side comparison just to check the differences.
no, to me they seemed the same. When I first went to run it, I did notice that like the simulator, it might not have worked exactly right, or there were errors. So that's when I said, "Oh, I'm going to go ahead and
Yeah.
um,
So like right now, it's stuck because it couldn't avoid the wall there. So.
yeah, I see that." Which hopefully I ran the right one. Yeah, no, I did. It also seems to say not found.
Mm-hmm. No.
Let me.
Okay, that means the Python script maybe did not start the node correctly. You can.
Oh yeah, yeah, right here. So I'm gonna break out of this
Mm-hmm.
and break out of this one and go back to this one. Actually, if I if I break out of here too, it'll put the robot back in a friendly position.
Mm-hmm. All right. So maybe as it loads, we can talk a bit more about some of the basics that we think that we should know, right? So if you were going to make modifications to a script in the terminal, right? Which tool would you use? For example, what is available in this environment already is Vim, for example, right? Can you show me a demonstration of that?
To use VI,
Yes. Yeah.
Yeah, I mean, I use this handy dandy code editor that you guys have provided.
Yeah, yeah.
But yeah, yes, if well,
Let's give it a
so
try.
this is running. Yeah, yeah. Okay, so say I created a new file. I'll say touch, oops, say test, and then I could do vi test.txt,
Hmm.
and then um,
Inserting values or text.
well, maybe I'm not so.
You're writing and exiting.
Yeah, I did that. Let me do something like this. So, huh.
So, can you explain what you just did?
Well, I was gonna try to copy. I was
Information
gonna
here.
try to put. Yeah, I was gonna try to. So I have something to.
Press I.
Uh,
Yeah, I think the one thing you're looking for is I. So if you press I or escape
oh,
or
okay,
reset, then you should be able to edit and
okay.
deploy the script. Yeah.
So yeah, I forgot that but I do know if I do the the colon,
Mm-hmm. But you have to be in a non-modifying state, so you'd need to press escape.
yeah, which okay, then colon right
Yes.
writes it, and then colon right Q
Right. Yes. So you are
saves
repeating the
it.
right process, but you could just use colon Q. But anyway, it's a good thing that you do know how to do that. You just need to perfect it
Well, yeah,
as we go
yeah,
along.
yeah. I think right now I'm a little bit. I don't know what's going on with my cursor, but it's not. Oh, it's down there.
Okay.
Nope. What's going on?
Let's try reconnecting one more time. I think to the simulation now.
Yeah. So I have my Pi, which seems to be working. I don't know why it canceled before. I don't know what this terminal is doing. Um, so I need one more. This one, I'm going to load my statistics, and this one will be the simulator.
Mm-hmm.
Yeah, I don't know why that one uh,
So,
crashed into the wall before, except that you were right that this Python failed, and I don't know exactly
all right. So,
why that was.
you can you connect to the sim one more time? So you do
Oh,
understand
this,
the difference between the the window on the left and the one on the right, right?
um, yeah, this one is providing what I call telemetry of the actual robot. Um, reading, it's the sensors that would be on it, and this one is showing where the actual things are. Like, I'm not so good at zooming in, but so like this represent like when they created this model, they placed these things here, and then this one is reading the one on the left is reading the actual sensors, like this is the LiDAR and whatever sensors the robot has in this simulation.
Mm-hmm. Yeah. So
Um,
the one on the
this
left is
this
basically for displaying your sensor data, right? It's for visualizing
yeah.
whatever sensors you have got on your robot so that you can see the data in a way that you can comprehend as a human. And then what's on the right is basically the simulated environment. So when you're not connected to the real robot, this would be an alternative to that because you are using a virtual environment to um, practice and learn about what your robot's behavior will be, right?
Right. Yeah, if I wanted to put some crazy terrain in there or whatever, I would do it in the model, and then what's on the left is the reading of the sensors. And I could actually use what's on the left. If I had a real robot, it could actually show that. Um, it could show what visualize those what are coming from the sensors from a real robot as well.
Definitely, yes, definitely.
And for mine, I use a program called Foxglove.
Okay, all right. So you have used that. That's good. That's good. Yeah, that's basically the same. Not the same thing because they're made by different people, but yes, that's
Yeah,
pretty
yeah,
much, yeah.
yeah,
All right. Thank you very much, David. So we are glad you took our course and you found it helpful, and we look forward to seeing you again. All right.
yeah,
All right. So
definitely.
what I'm gonna do is I'm just going to wrap up our conversation here, and you hang around for me so that we finish our conversation on Zoom. All right, everyone. This was David's presentation, and would like to thank him for coming here and making the presentation. I am also going to highly encourage all those of you who would want to try this course, Linux Basics, or all our entry level courses, as well as the other ones that we offer certification on to do so. And you can also come and showcase your work. And until next time, keep pushing your ROS learning. Bye bye.